For today's lesson, we're looking at true and false statements. We're going to look closely at problem number 6. We write this as 32 times f is less than 64. For our true statement, what we need to do is first analyze the problem and find out which operation is connected with our variable. Since we know that 32 right next to f means multiplication, I need to look at it and do the opposite of that operation in order to get f by itself. Since the opposite of multiplication is division, I divide 32f by 32 in order to cancel out the 32, leaving f by itself. In order to keep the inequality balanced, I have to do the same thing to the opposite side. So 64 divided by 32 is equal to 2. I drop down my inequality, and I know my true statement would show that f is always going to be less than 2. Now, if any value for f is always going to be less than 2, that means my false statement, or the values that would prove the inequality false, has to be all the other numbers. And we write that like this. F is greater than or equal to the value of 2. Let's look at an example. Still looking at number 6. If I plugged in the value of 2 for f, is it in fact less than 64? Well, when I evaluate 32 times 2, I get 64, which is actually equal to 64, and not less than, proving this to be false. To review, we did a few things. The first thing we did was analyze the inequality to find out what operation is connected with our variable. The second thing we did was to find the opposite of that operation and do that to both sides. So when I divided the 32 with the 64, I found my answer as 2, and I kept the same inequality sign, showing that my true statement was f is less than 2. And the false statement was anything besides that number, showing that f was greater than and equal to 2.